Good morning. This is John Balcone. I'm the Vice President of Sales for LMGI. I want to welcome everybody this morning and thank you for joining our Digital Machine Shop webinar. This will be time well spent. We'll keep it on track and leave some time for Q&A at the end. This will show you how using our NX products will be able to cut your manufacturing time, make you more efficient, and have you gain profitability. Also on the line this morning, we have Jason Titcomb. He's our technical lead, and he'll be giving the presentation. We also have Rick Loring, the president of LMGI, and again, John Balcone, myself, VP of Sales. Again, thanks for joining, and if you have questions, you can either type them into the box there as the session is proceeding, or you can save them till the end and ask them during the Q&A. So with that, Jason, I'll turn it over to you.
Great. Thanks, John.
Go ahead, Jason.
Thanks, John. I'll keep you on for a couple minutes to make sure the slides are advancing okay here. So welcome, everybody. Thanks for joining. Today's theme, as John said, is the Digital Machine Shop and the advantages it provides to your company. We're going to start with some of the key drivers in the industry here.
They're advancing.
Okay, thanks, John. Over $45 billion in revenue passes through manufacturing in the United States. This is just in the United States. Almost over 250,000 workers. That's a pretty big economic impact. It's really amazing numbers there. So machine shops support many industries, as you know. Some of our customers focus on one industry, but some machine shops support multiple industries, any one shop. Each of these industries might have a little bit different requirements, but they all share some of the same challenges, the biggest one being increasing throughput. And that's one of the key competitive pressures of a manufacturing business is increasing your throughput. But you at the same time have to maintain quality. You have to always keep that. You can't sacrifice quality by speeding processes up to where they get unstable. And then as a business owner, you need to kind of always keep your eye on new trends, what's happening out there, next generation products, and think about how to stay ahead of your competition. More than interesting stats here. More than half still use a standalone CAD and standalone CAM, so separate systems. So there'd be one guy that knows the CAD and another guy that knows the CAM, and there may be some crossover, but two separate systems to learn. And apparently, very few manage their data in any kind of a system to keep it under control, so they always have the correct version sent to the floor. And very many people still have a completely disconnected measurement system with their CMMs. A lot of people still using paper. We still see that a little bit, but as those drawings go out to the floor, they're uncontrolled, and if there's an issue during the process, you have to go out and manually retrieve those. So that's a weakness in the system. So if you could imagine a manufacturing system where the people and the systems are completely connected, this is what Siemens calls the digital machine shop. Using integrated systems, it enables you to be more efficient and have that manufacturing information flow through the process, connecting all the steps from engineering down to manufacturing. So we'll take a look at some of the software technologies. You'll also hear the term digital twin quite a bit from Siemens. I think it makes sense. It's an exact replica of the real world model. It's your digital specification is another term. So the digital twin starts with a smart model of the machine part and then flows through the various steps to get to the shop floor. Model preparation, sometimes there may be some adjustments for manufacturing needs, maybe design some fixtures. You'll be able to do that quickly, all working within the single NX platform. Creating associative drawings is also very important. If a change happens in your process, you want your drawings to update automatically, and Siemens NX does that for you, working within one platform. In parallel, your quality team can work independently to prepare for the inspection process. They can leverage the PMI data that is on the model to accelerate creating their inspection programs. We showed that in another webinar a little while ago. And if anything happens, anything changes with the design part, that PMI, or product manufacturing information, will update automatically, and it's very quick to just simply regenerate that inspection program, even after you've made adjustments to things like maybe how many touch points and things like that you have. So it's one system, one model. You have this kind of a digital thread that runs through the entire manufacturing process. It's a very model-driven process. And it's the key tenet of the digital machine shop, that model-driven process. Having complete associativity by working within one system, you have that concurrent workflow and accuracy and reliability. So here's a short demonstration. Take us through the entire process, starting with model preparation. Any standard CAD model can be opened in NX, of course, or you can design right in NX. But often manufacturers will receive CAD data from other systems. So fixture design is very easy. You see here making some associative additions to this design for fixturing, defeaturing, maybe with the intent of creating a casting or replicating a previous, what if you want to make a blank or a stock. But again, you're working with the same model, and when you make those edits on top of that design model, it's all associative back to the original. CMMs can leverage, as I mentioned, that PMI, product manufacturing information. You can see that the system just recognizes it, generates the inspection points, and you're free to make adjustments to these after the system uses your best practices that you can set up. On to the manufacturing. At the same time, that model is used in the CAM environment, secondary machining operations, and so on. You can see just some examples here of some complex motion, and the visualization is very important. We'll see a little bit more about that later, and the 5-axis capabilities of NX are quite powerful. And of course, it's going to create very machine-specific NC code, can be for any controller out there. Shop documentation, easily produced to help your manufacturing guys get set up. So what about when something changes? The customer sends you a new model, or somebody changes their mind to the specification. That master model just simply needs to be updated, and all your other downstream processes like your CAM and your CMM, you could see, just regenerate the toolpath and accept. You run that through your simulation again, and you'll be ready to go. CMM is the same way, completely associative to that digital twin with the master model. Just simply update those inspection paths, and nice testimonial here. This company, Telsmith, they make rock crushing machines. These things are big, expensive material, long cycle times, big machinery. Things need to be done right. Mistakes are expensive. So really good testimonial on how they measure cost savings. So ideally, manufacturers want to use a single cam system. Some still have multiple cam systems, and there's often not a need for that. NX has specific areas that its cams, it covers all your cam challenges, everything from mold and die, where the focus is on producing a high quality finish, so there's less finishing time after when the die comes off the machine. Sometimes handwork needs to be done. Production machining has its own challenges. You're talking about high quantities of parts, so multifunction machines. And then you have your complex parts. So these three different categories: complex parts like aerospace, medical. What you really need there is lots of control. 5-axis machining typically. High control over your tool axis and how you cut the part. So you can see there's different challenges. So for mold and die, NX offers high-speed roughing. They have what's called adaptive milling that utilizes the new state-of-the-art techniques of keeping that tool in the cut, utilizing as much length, a very high-speed roughing strategy, utilizing the full length of that tool so you can maximize your investment on tooling while at the same time extending tool life. Some advanced finishing techniques. There's streamline path that tends to flow along the curvature shape to minimize the amount of finishing work that needs to be done. And there's also some point distributing, some point alignment. Adjacent paths can be aligned so that they, as you go from one pass to the next, the machine tool can actually produce a much better finish when combined with some of the compression technologies in the machine control. And multi-axis machining can also be leveraged in mold and die. In fact, NX has a really easy to use command to convert existing 3-axis toolpath into a 5-axis toolpath. Will allow you to utilize a shorter tool possibly by tipping your machine to access, in some tight areas. But it's very easy to use. You just create your 3-axis toolpath and then just ask it to tip it, but keep the tool holder away from the part. For high production, the volume-based milling was introduced some releases ago to accelerate some of the simpler operations like face milling and pocket milling, where you get this very volume-based boundary creation. The system automatically finds where the material is and creates paths based on that volume-based, and it gives you feedback immediately, just even as you're typing in numbers in the changing parameters. It's giving you feedback as far as maybe the cut levels. They immediately show up on the screen. Multiple part programming is also utilized heavily when you have a large quantity of parts. So NX has great support for that. They track the material as it travels from maybe one side of the tombstone to the next, using the finished part as a reference throughout the whole way. And multifunction machines, of course, you see them everywhere now. They can do milling, turning, and drilling all in the same machine tool. Some of the challenges there are it's a very complex machine, possibly more than one program running at the same time. You need to make sure different turrets aren't interfering with each other, or you could be doing some turning on a main spindle and a sub spindle, that kind of thing. So very complex. So the visualization and the simulation is very important. And then for your complex parts, there's a comprehensive set of 5-axis tools in the software, probably more axis control than anybody out there. And the visualization, error-free machining, so it looks pretty good. So you could see that NX covers all these areas, so you really don't need separate systems. You can really use NX for all your different wire EDM, 2.5 axis milling, 3-axis milling, turbo machinery for turbines, turning. We'll talk more about the feature-based machining, and then it usually finish up with an accurate machine tool simulation. Another quick demonstration. Here's a little example of how easy it is to simply sometimes just pick one face and get toolpath. The software uses the volumetric technique to find the boundaries of that material and create that toolpath without you having to create all these other boundaries. No more drawing sketches, things like that. Multiple setups as NX transfers from one setup to the other. It knows where that finished part location is, and it knows what was previously machined with this in-process workpiece. You really just need one system for this. Multifunction machines. Here's a great example of kind of a complex mill turn. Even simulation of the spinning chuck. Your clearance changes if the chuck is turned on. If the chuck's not running and you're in a milling operation, you could possibly position that and get in between the jaws. But if it's turning, not the case. The manufacturing resource library sits on top of Team Center. We'll talk about Team Center a little bit more. It's a way to organize, find, and categorize all your fixturing and cutting tools. You can see you get some really great visualization within that system, but that's what you're seeing here, Team Center. NX talks directly to that system. Another example here of how you can automate programming for various setups. It's a simple copy and paste operation. You can see there's a roughing and some drilling operations. You just simply copy that and paste inside with reference. That's kind of like, maybe think of it as a sub-program. So it's very fast, very easy to use. And then the simulation is G-code driven. Again, we'll talk a little bit more about that in this presentation. Very important when you have these complex multiple part setups. Volumetric material removal, of course. You can see the G-code reporting back. And having the ability to jump into your CAD system, right within the same platform and add to your fixture. Maybe at some point you wish you'd made a change to the fixture. You don't have to jump out to another system. Stay within the same platform. You see an example here of using some of the assembly capabilities in NX. NX is probably, if not the most, arguably probably the most powerful CAD package on the planet. Drawing capabilities built right in, complete, and it allows you to create complete documentation for your shop floor. Shop floor documentation can be created also from within the CAM system to give your guys all the information they need to make those parts. By digitizing your manufacturing process, you can kind of unite the virtual and physical worlds. Here you're seeing what's called Shop Floor Connect. That's how you send your programs to the machine tool. It's all controlled by Team Center, so that if there was ever maybe an issue with the CAM, it can be retracted. And you can always be sure that you're delivering just the released version of that NC program to the floor when the guys need it. So to automate processes to increase your throughput and improve quality, NX provides feature-based recognition. The software can determine what is a pocket, what's a round pocket, what's a hole that needs to be reamed or just drilled. It allows you to achieve consistent results, and you can also teach the system to recognize specific features that you encounter frequently in your products. So over time, you can use this continuous improvement also by leveraging the PMI. We mentioned that earlier with this CMM. The PMI data, product manufacturing information, can be leveraged with the feature recognition to help it understand whether it needs to just simply spot drill and drill, for example, or spot drill, drill and ream, based on the tolerances that it finds in that PMI information. Companies have found they can reduce programming time by up to 90%. I know that sounds pretty optimistic, but it takes just as long as a computer takes to crank out a few processes, and automatically finds tools, creates your operations, does all that grunt work for you. It's really interesting. Powerful way to automate NC programs, and it really just creates things that you would, as a human, would create anyway. It doesn't create these magic black box type operations. They're completely editable after you create them. The tools are brought in just as they would have been normally, and it helps you ensure consistency also. Maybe you have some new hires, they need to get up and running very quickly. They can use this feature recognition to get themselves really close to where they want to be, to speed up the NC programming, sometimes as much as 5 times. So validation, a big advantage of having that digital twin of your part and complete machine setup is the ability to validate the process early, so you can find if there's an issue before it hits the floor and causes slowdowns or stops in production. You want to avoid that kind of thing. It's much cheaper to identify to fix a problem in the digital world than it is out in the physical world. I'm sure you know that. G-code driven simulation is really where you want to be. NX provides that. It's a great way to be confident. You can be extremely confident that the code that you're using to simulate your digital twin is exactly the same code that's going to run the machine. So the same logic that happens at the machine controller happens inside NX. So it's just this higher level of confidence that will allow you to get that program perfect before you send it to the floor. So in summary, the G-code simulation allows you to accurately validate your machine. It gets kind of much more important when the machine complexity gets higher. So it's maybe less interesting when you're only using a 2-axis lathe, but then when you get into a multifunction machine with dual channels, it gets very important. You have things that maybe control the bar puller, that pull material from or transfer material from the main spindle to the sub spindle. All that is simulated within the system, so it really gives you a higher level of confidence. You saw earlier, machine shops need to be able to read and work with almost any CAD data out there. You saw that on the very first slide. NX can read, virtually any other 3D systems file, but NX can also allow you to make changes to these designs with the synchronous modeling. Maybe it's because of manufacturing reasons. You find that it would be a little easier to use if you change the size of a radius, for example, within the design requirements, so that it allows you to use maybe a little bit larger end mill, or to prevent a ball end mill from bearing into a corner, that kind of thing. The synchronous technology really excels in that area. Very easy to use, and the tight integration right within the CAM system means that you can just simply use it without jumping out to another platform. As mentioned, the CMM software is can automatically create your inspection programs using that PMI information, and that is really productive. If that specification information is in the model, why should you have to redo that in your CMM software? Just use that in just the same way that a human would look at that feature control frame or that tolerance on a drawing and bang in numbers. The computer interprets that and creates the operations for you. That you can teach it. NXCMM also allows you to get information back from the CMM, though, to create this closed loop solution that allows you to easily compare the result inspection from the actual design requirement. It can be helpful to troubleshoot processes. Maybe think about it'll help you reveal if it's maybe a work holding problem or whether you're not sufficiently roughing the part maybe and it's relaxing the material. That closed loop is very important. Another great testimonial from a large mold manufacturer, very large mold and dies, lots of material removal. So what about new technologies? We talked about that. As a business owner, you need to always be looking what the competition is doing, what's the next big thing. Siemens and NX, they're on top of that as well. Robotics machinery, this is something you typically saw in the past in the automotive industry. You always, you saw the production line, these robots at the car makers, but we're starting to see them everywhere now. People start to understand how they can save money. Maybe it's a hazardous environment. Maybe it's a lighter post machining operation that it's a little more cost effective to let me back up one more, a little delay. It's a little more cost effective to have a robot do these minor subsequent operations instead of tying up a very expensive multi-million-dollar machine tool. Or it could be as I said, hazardous environments, or sometimes these machines are also used for pick and place, for loading and unloading parts. So they're used for machining as well as part placement. And NX CAM has the capabilities to program both situations, part loading and manufacturing. There's special considerations for those 6-axis robots. Additive manufacturing is another technology. It's amazing how quickly this is growing. Of course, it's always referred to as 3D printing, but it's definitely a transformative technology. The idea of building your parts up by adding material instead of cutting away, or sometimes what about a mixture? Do some additive and then use your subtractive within NXCAM to remove material, maybe in a more higher accuracy way. So you can actually combine both technologies in the same platform. According to, I'm looking at my stats here, there's 75% of companies are already adopting some type of 3D printing. That's pretty amazing, 75%. They may be using 3D printing to make prototypes or for work holding, but some are actually using this technology to produce parts. Here you see a typical powder bed fusion on the left and the new HP multi-jet on the right. So NX provides capabilities to work with these different machines. They have each different process might have a little bit different challenge. Sometimes you need supports. in the way of lattice, things like that. You're even seeing hybrid additive machines from DMG Mori. Siemens has a tight relationship with DMG for this so-called directed energy deposition technique, where the material is kind of blown on as a powder and welded on. This allows you to actually build up parts in not just a planar method, but in a three-dimensional process, because you're not working in a powder bed. You have this freedom to possibly move ahead in multiple axes. And then, of course, you could do your 5-axis milling right there as well. In the lower right, you see the multi-axis fuse deposition modeling happening. It's pretty exciting stuff. So what about information flow? Manufacturers are creating a lot of data. You know, what should I be working on? What's the latest release? This data hopefully would become useful information. Siemens provides Teamcenter for a system to control and store your information in a very controlled manner. Everything is covered in Teamcenter. Virtually any electronic data, for that matter, can be stored within Teamcenter. So all of your design data, all of your fixturing, all of your tooling, CMM inspection, it brings together the CAD, the CAM, the CMM, all comes together with Teamcenter. The manufacturing resource library, we saw that earlier. This gives you a central access point for all your cutting tools, fixtures, and other resources that your entire company might need. Tooling based on your standards. And when you've got the work package, you validated it and checked it, you need to send it to the floor. In many cases, right now it's done inefficiently by taking the paper drawing out to the floor and maybe walking out there with a memory stick and putting it in the machine. But Siemens provides a really efficient way using Teamcenter and the Shop Floor Connect to be sure that those machines only get the program that should be running on them. And as I said, it could be retracted if there's an issue. This diagram pretty much represents the complete solution that can be stored to integrate everything you need, centralized data, everything from planning to production. Another company that's taken advantage of this technology, they've connected their entire operation, eliminated these transfers of data. They've improved collaboration and automation. They all deliver big benefits to the company in the form of improved productivity and reduced manufacturing costs. Helps them stay competitive. So we covered a lot of ground today. Hopefully you found this information useful. We discussed the unique advantages that Siemens NX and the digital twin and the digital machine shop delivers, including increased throughput, improved quality, and the ability to expand your business with new technologies. So if you want to learn more, there are some links here. You can go to Siemens' website, contact us here at LMGI. You can find our website, www.tlmgi.com or lmgi.us. And you can even get a free Manufacturing 360 tablet app. So thank you all for attending today, and we hope to be hearing from you.
So I got some editing to do.